Hello, this is the luckiest maths teacher in the world, and today we're just going to review the mean, median, mode, and range. So when we talk about these things, we're talking the mean, or the median, or the mode, or the range of a set of data, which is just a list of scores. So let's say I have the scores 10, 12, 11, 12, 11, and 31. So I've got 6 numbers here. So I'm going to go through and find the mean, median, mode, and range of all this. So first off, the mean is the average. And that is sum of all the scores. So you add them all up, and then you divide by how many there are. Now I'm going to write sum of scores divided by n. N is the number of scores. So I know you probably already know most of this. I just want to make sure you're not getting mixed up between mean, median, mode, and range. So the mean in this case would be 10 plus 12, so you get the idea. Just add them all up. And we divide by 6 because n is 6. There are 6 scores. So the mean here is just adding them all up. 87 divide 6 and you get 14.5. Now note the mean does not have to be one of the scores. Alright, second is the median. Now the median is the middle number. Now what makes the median a little bit more complicated is that we find the median differently depending on whether they're an even or odd number of scores. So in this case there are 6 scores, so there's an even number. So we want to find the middle of them. There will actually be 2 middle numbers. Now, they have to be in order from smallest to largest. So the data up there is not. So first I'm going to write it in order from smallest to largest. Now, there are 6 scores, and the median is the point where there are the same number of scores above it as below it. So here is the median. When there's an even number of scores, or 2 middle scores, you add those 2 up and divide by 2. So halfway between 11 and 2 basically. So 11.5 is the median in this case. So again, it does not have to be one of the scores. Now a quick way for the median is it's the n plus 1 on 2th score. So in this case, n is 6. So the median is 6 plus 1. 7 on 2, which is the 3.5th score. That doesn't make sense, but when you get a decimal like that, the 3.5th score means the average of the 3rd and the 4th score, just like we did here. Okay, the mode is probably the easiest to find. It's just the most common number. Now, in this case, there are 2 numbers that occur more than once, 11 and 12. So this actually has 2 modes. In this case, we say it is bimodal, 2 modes. So you can have more than one number for the mode. You can also have no numbers for the mode. If you have a data set like 1, 2, 3, 4, 5, and no number occurs more than once, we say the data has no mode. Now the mean, median, mode, they're all about telling you the center of the data. They're different calculations, but the idea is to give you an indication of where the center of your data is. The range, however, is different. It's telling you about the spread of the data, and it is the highest score minus the lowest score. So, in this case, highest is 31, the lowest score is 10, so the range is 31 minus 10, which is 21. 21 doesn't tell us the center of our data, it tells us about the spread of the data. Now, the other thing I need to mention here is this concept of an outlier. So an outlier is one of the data points that is much larger or much smaller than all the others. Sometimes in, say, science experiments, they'll actually leave these outliers out of their calculations. So in our data up here, the outlier is 31 because it's much larger than all the others. So outliers affect each of these things differently. So they obviously affect the range because the outlier will be like the smallest or largest, so it can make it larger. So if I take out the outlier, so then let's look at the data with just the other 5 numbers. So the mean would actually be, so they added up to 87 before, so now they'll add up to 56 and there are 5. So the average of these will be 11.2. So there's a bit of a difference there. Now if you look at the median, now if there are only 5 numbers, an odd number, then the median will just be the middle number. So again, I'm going to write them in order. And now there are 3 numbers. I can use my formula over here. So n equals 5. So 5 plus 1 is 6, divide 2 is 3. So the median is the third number, which is 11. So it's changed only a little bit. The mode, however, has not changed at all. It's still the most common number, and it's still 11 and 12 bimodal. So outliers affect the mean more than the median or the mode. I just want to do one more type of question for you, and then I'll let you go. Alright, let's have a go at this question. So Darius Boyd, who's a wonderful Brisbane Broncos player, has played 15 NRL games and averages 1.8 tries per match. So in his next match, I want to know how many he has to score so that his average will be 2 tries per match. Okay, so we know that the mean, or the average, is the sum of scores divided by n, which is the total number of scores, right? So if you know the mean and you know how many scores there were, we can just rearrange this. So the mean times n equals the sum of scores. So we can figure out how many tries he scored, and then we can figure out how many tries he needs to have scored so that his average is 2. So if he has scored at 1.8 tries per game in 15 matches, he has currently scored 1.8 times 15, which is 27 tries. So that's how many tries he has now. If he wants to average 2 tries a match after 16 games, then he needs to have scored 2 times 16, which is 32 tries. So obviously, the difference is just 5 tries. He has scored 27, he needs to score 32, so he needs 5 tries in his next game. So in a question like this, make sure you give a worded answer. Therefore, he needs to score 5 tries in his next match. How easy was that? Hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.